My name is Matt McClean. So I lead the Annapurna customer engineering team. So my team essentially help customers adopt AWS Trainium and Inferentia for their workloads. So I work for AWS. I've actually been working for AWS for more than 11 years now. And I've been working in the Annapurna and AWS Trainium team for a couple of years. And how I take my coffee? Well, my wife's Italian, so I prefer to take it in Italy and a cafe place with Italian coffee is how I prefer it.
Hello, my name is Kamran Khan. I lead our business development and go-to-market teams around Inferentia and Trainium. And I like all types of coffee. So generally, at home, I'll make myself a flat white. And on the go, I like a variety of kind of light to medium roast drip coffees.
Welcome back to the MLOps Community Podcast. I am your host, Dimitrios, and we're back with another banger. Today, we're talking to Matt and Kamran about Inferentia and Trainium, these two AWS services that were demystified for me. Over the next 40 minutes, I got the deep dive on what exactly they're good for, what they're not so good for, how they work, what they work with. If you're using SageMaker, do they work with that? If you're using Bedrock, how can you utilize them? Why would I even utilize them instead of the common GPUs? And what are their strengths? They really break down why they created both of these, which are basically, they said, you know what? We want a chip that is tailor-made for deep learning workloads. And so, you know how Amazon and AWS like to do it. They just went out there and they made it happen. They turned it into a reality. We talk with Kamran and Matt all about it. If you like this episode, as always, share it with a friend. We would love to hear from you on the Spotify feedback section. That's always great. I get a nice little chuckle when people send in funny comments. I read every one of them, and let's get into it. I'll see you on the other side with Matt and Kamran. All right, so Matt, I got to call it out first. You were in the community in 2021. I was just looking at our conversations in Slack from 3 years ago. It's awesome to finally get to have you here on a podcast, but it's almost like we get a 2-for-1 today with Kamran too. We want to talk all about AWS's Inferentia and Trainium. It's probably a good place to start with just giving us a rundown on what it is and why AWS has invested in something like this.
Yeah, absolutely. So we've been at AWS been investing in different types of accelerators and use cases for customers for a very long time, right? And so as the AI revolution has really taken hold, and I would say I think the interesting part is, right, like most consumers or most people are really picked up on AI with the introduction of ChatGPT last year, right? Where they're like, oh man, look what AI can do for me. Look what these large language models can do for me. But I think, us in this community have been seeing this trend for the last 10, 15 years, really since ResNet really started showing the potential of what models can do and how they can kind of start providing, more superhuman responses to simple applications like computer vision and classification, but now with language, with video, with images and so much more. So because of this, AWS has been looking at this space and like, well, how can we offer customers more choice, higher performance, lower cost, of course, right? And make it easier and more accessible to more users and developers and customers ultimately, right? And so they started investing in our own generation or purpose-built accelerators, our AI chips called Inferentia and Trainium. And we launched our first Inferentia AI chips back in 2019. And in 2019, it was Inferentia 1, focused on inference acceleration, and it was really good for CNN applications like YOLOs and ResNets and image classifiers. And then time is flying, right? In 2022, we introduced Trainium. And Trainium really was designed as the successor to Inferentia in some regards. It was our second ML chip. This really brought a lot of modernizations and really focused on LLMs and generative AI and how to accelerate and distribute large models across multiple accelerators and make it very efficient and cost efficient as well. And then last year, we introduced Inferentia 2, the successor to Inferentia. So now we're building kind of this family of accelerators, basically to provide users choice, right? So give them opportunity to, get higher performance, lower cost, make it easier and more accessible for more users. And we want to continue to invest in these types of accelerators, right? So Trainium 2 was announced at last reInvent by Adam, and it's going to be available later this year, but it's going to come with 4x higher performance than Tier N1. And we're pretty excited about what that's going to open up and what the possibilities that's going to open up for a lot of users as well.
So I love that you're talking about the choice and bringing more choices, because Amazon is kind of known for that, especially at AWS. They're known for all the different choices. And I want this conversation to really be around like, when would we use it? Why would we use it? And what the strong points are, the weak points and whatnot. Of course, the first question that comes to my mind really is about, how does this compare to a GPU? How is it different? What are things, how does it match up, right? Like, and what GPUs, what should we expect? There's like a lot of unanswered questions that I can imagine people are sitting at home or in their cars listening and thinking like, okay, cool. So Trainium and Inferentia, it's like GPUs, but not?
Yeah. So we have designed Trainium and Inferentia really to be a super specialized accelerator for deep learning applications. So, GPUs, originally were, they're a graphical processing unit, right? So they were never designed for deep learning workloads. But obviously it's a great fit. But we decided to design something really specific to deep learning. So I guess the key difference is, comparing a GPU and our hardware, was that a GPU, you have a lot of these, streaming multiprocessor, lots of, thousands of cores and tensor cores. Can essentially, what is a deep learning application? Why do you need an accelerator? It's primarily to, I would say, a couple of core things. One, you need to accelerate matrix multiplications, right? The linear algebra, calculations. So that kind of forms, I think, more than 90% of the operations or the T-flops, right? And any, this is for both training and inference. So you need something because our standard, CPU is just not fast enough. So GPU is good for that. And what we provide essentially in our hardware is what we call a tensor engine. So it's actually a, systolic array that can really accelerate these matrix multiplications. So it can do, for example, a 128 by 512 in a single, clock cycle. So really, really it's designed for accelerating those matrix multiplications. The other part of accelerators that is needed is really high bandwidth for memory, right? And in this respect, they're quite similar. So we also have HBM, right? And it's really designed to, take the weights, gradients, and so forth, that's stored, and then, really quickly move them into the, the cache, move it into the accelerators to do the computation. So that's kind of the other key part. So yeah, so the main difference I would say is the way computation is done.
Okay, and that's through the tensor engine. I like that. And I can imagine people are going to want to know like actual numbers and benchmarks. And so we'll leave a link to a blog post, but do you have any numbers off the top of your head?
Yeah, some numbers up. So of course, I think the best place is going to be our documentation. We publish actually a range of different benchmarks and kind of like hardware specs as well, right? So you could learn exactly what the T-flops are. But for training applications, we kind of like to think about what is the effective T-flops you can achieve while training, large language models, for example, right? And so we like to kind of look at what is our effective T-flops per dollar. And so when we look at that and we compare it to, traditional accelerators on the market on AWS today, we're able to lower the cost to train models by up to 46% using Tier N1, even against kind of like the more common or, like latest generation of other accelerators available on AWS. So it's very competitive. And at the same time, on the inference side, we see a very similar story as well, right? So with the kind of conscious decisions we made in our hardware, really specializing on just these machine learning workloads rather than trying to be general purpose. Like, for example, we get this question quite a bit is, can I run crypto algorithms on Inferentia and Trainium? Or can I do like graphic simulation on Inferentia and Trainium? Going back to your earlier point of I think it's like a GPU. So can I run other workloads that require that level of horsepower? And the answer is no. We can't actually run crypto algorithms. We can't run, simulation workloads. And not that the hardware necessarily can't support it. It's like we haven't invested in the software stack to enable them because we want to be specialized. We want to be focused. And that gives us, the ability to really hyper-tune, lower cost to train, up to 50% lower cost to train models. And at the same time, when you're deploying models, get higher performance and reducing your deployment cost by, up to 40% as well using Inferentia too.
And I like this idea of, all right, you're trying to make sure that you're looking at the price of training or the price of inference, and you're seeing that it's going down like 46%, which is not a small number. And I like that number especially if I'm thinking about spending a lot of cash. Yes. If it's 46% less, that's a good chunk of change right there. And the next obvious question I think I have, just as someone who is not super familiar with Trainium or Inferentia, is, do I still use CUDA? Like, what do I work with Inferentia and Trainium on?
Yeah, so we don't support CUDA. So CUDA is, a library very specific to GPUs and very specific to NVIDIA GPUs. So what we have instead is our own, we call it SDK. It's the Neuron SDK. And so what that comprises of is essentially think of it 3 blocks. So we have the framework integration. So for example, we work with PyTorch. We also work with TensorFlow, typically for inference. And we're very soon going to have JAX support. So basically the first part is to tie in. So basically what we want to do is allow our users to stay in the ML framework that they prefer, right? Minimize the sort of code changes they need to make to use our purpose-built hardware. So that's kind of the first part of the SDK. Then we have the compiler itself. So our compiler stack is based on XLA. So XLA was originally part of the Google TensorFlow project, but is now, and we're one of the founding members of the Open XLA initiative. It's an open source initiative. So there we work with Google, we work with others like Meta, NVIDIA, Apple, other companies in terms of evolving the XLA standard. So that kind of defines all the operators and that kind of get lowered, in compilation flow, and uses an intermediate representation called stable HLO to define all those operators. So our compiler uses HLO, and then it compiles essentially, the computational graphs, forward, backward pass, optimization step, all into low-level machine code, right? And we call that the Neuron executable file format. So basically that runs, the specific commands on the different engines in our accelerator. And then these NEFs get run on the accelerator by a runtime. So the runtime executes these compiled artifacts and also does a lot of the networking, right? So when you're doing a distributed inference or training job, then you have all these collective communications, right? You need to communicate between the different accelerators. So the runtime also handles that. So with all these kind of components, you kind of get end-to-end coverage of our software stack to enable you to run your, PyTorch, your code on our accelerator.
So if I'm understanding this correctly, you're really trying to allow people to use PyTorch or TensorFlow or whatever they're used to using. But then, and if you want, you can just stop there. But if you want to go deeper, you can through Neuron?
Yeah, you can. There's a few different ways. So for example, if, most users would just use, standard PyTorch and then, compile their model for PyTorch. We use the XLA version of PyTorch, right? That is also used by Google when running on TPUs. So most users can just stay, writing their code on PyTorch and it'll work fine. If they want to have more control, then there's a couple of different ways that people can, get better performance. Or for example, if there's a certain operator that we don't support and they want to implement that, then they can actually write their own custom C++ operator. So one of the engines in our accelerator is a SIMD engine. So you can write C++ code to execute custom operators, say a PyTorch operator, and that will run on the accelerator. In a couple of months, we're going to have a new kernel interface. It's called Neuron Kernel Interface, or NIKI for short. And this will provide if you're familiar with Triton, so, there's many customers that want to, further optimize performance. And they want to do we call it kind of tile level computations, right? So we're, reduce the amount of kind of memory transfers between HBM and SRAM. So if you're familiar with, for example, the flash attention algorithm, right? That is the core, that's how flash attention works. It's operating in SRAM rather than going back and forth to HBM. So you can implement algorithms like flash attention, like Mamba, using NIKI that will be launching very soon. And that's another way that customers can, get further performance, have more control over, how the code is run on our accelerators.
And is it only, do they have to go together? Are they married or joined at the hip type thing? Or if I use Trainium, then I can use whatever else I want, and I don't necessarily need to be stuck in with Inferentia?
Yeah, that's actually a really important one, because we get that question all the time, right? If you utilize or let's say you're starting with Trainium, you train your model and fine tune your models, starting from, let's say, Meta's Llama 3 model, which is, a great choice to start. And then you fine tune it. It's working great for your application. Are you locked in? And the answer is no. Our kind of philosophy is try to be part of the heterogeneous world. I think we know, working on and building with Inferentia and Trainium and the software stacks around it, that users and developers are going to be pulling and, mashing together different libraries and environments that will be best for them, and maybe not for everyone, but it'll be best for them. And so the idea is we want to work within that world. We know it's going to be a heterogeneous compute environment where you're going to be utilizing CPUs for certain tasks, GPUs for certain tasks, and Inferentia and Trainium for certain tasks. So when you're training a model with Trainium, you could deploy that model, or I should say that the entry and exit, let's say you're fine-tuning that model, is going to be starting from a checkpoint, right? You could pick up Meta's checkpoints off Hugging Face, for example, fine-tune it with your data sets for your application space while utilizing Trainium. The output is just going to be another checkpoint that's defined by PyTorch. And then you can then deploy that anywhere. Inferentia is a great option, but you could pick up, any GPU or embed that model down if it's, for like an, on-prem solution or like an embedded device. There's a lot of wearables and, a lot of different versions now with we're seeing a lot of the AI wearables, right? Like with what Humane is doing, with what other solutions are doing. And then vice versa as well, right? So you could take models that are pre-trained or fine-tuned on Trainium and then deploy them to Inferentia seamlessly as well, right? Just kind of taking those checkpoints.
Mm-hmm. So basically, that's just one part of the whole workflow, right? Like if you're trying to go and do something with deep learning these days, or AI, machine learning, whatever you want to call it, you've got all the other pieces around it. And I instantly think about, how does this work with SageMaker? So that's probably where we could start. But then I want to know, okay, so what if I'm running Kubernetes, and what if I have Ray, or how does this fit with all of those different pieces of the puzzle? And so with SageMaker, that's probably the easiest one to start with, because I think a lot of people in the community and listening are using SageMaker. And then maybe we can go to Bedrock, and we can go to just EC2 or whatever it may be.
Yeah, I think it always starts with the team, right? Responsible for, either training or deploying the models, right? And what is their, for example, level of competency? What do they know today? What is their kind of maybe company, policy or standard, that they have to adopt? Because, a lot of companies will standardize on a certain technology platform, and kind of teams are a little bit, constrained to adopt to that policy. And it's always, I see it as a spectrum of ease of use and control, right? So taking into the capability of the team, taking the sort of that spectrum easy of control is kind of where you kind of land in terms of what is the best choice. Obviously, SageMaker is an excellent, AWS service, offers the full lifecycle management, and it has full support for Inferentia and Trainium. So, for example, there's kind of two options actually on the training side. We have the kind of the standard sort of ephemeral training jobs that maybe many of the listeners are familiar with. If you want to, using the SageMaker SDK or through Studio, you can like launch a training job. It'll spin up the instances in the background and kind of manage infrastructure. So that's kind of one option. We also have support for a new service that was launched end of last year, Hyperpod, SageMaker Hyperpod. So if customers are familiar with kind of a Slurm interface and more of a fixed cluster, right? They maybe want to have many different jobs or want to have long-running, say, training jobs, so they don't want them to be ephemeral. They want to sort of have a dedicated cluster. Then Hyperpod is a nice solution there, and it handles as well all of the kind of the failover, managing essentially the infrastructure when you have a hardware issue to replace the hardware, for you. So those kind of two options in SageMaker, and then on the inference side, we also have the endpoint support, so you can deploy to either Inferentia or you can even deploy to Trainium, because Trainium has a few more accelerators, more HBM memory. So for large models, say a Llama 3 70B, sometimes the Trainium actually a better instance choice for inference, for doing your inference of those models. So that's also supported in the SageMaker endpoint service.
Oh, interesting. Yeah, that is another piece to it. Like Inferentia basically can take whatever you throw at it.
Yeah, so maybe I can explain the difference between Inferentia and Trainium. So essentially at the accelerator level, it's basically basically the same. They have each accelerator chip has 2 neuron cores, so you can kind of think of a neuron core a little bit like a GPU. So Inferentia is essentially it can be deployed in more regions. It has lower power requirements because it has less chips. So in Trainium, we have 16 accelerators, whereas in Inferentia, we have 12. Also, the network connectivity between the instances. So we're using networking between the instances. So in Trainium, we have up to 1,600 gigabits per second network connectivity, whereas in Inferentia, we don't need, typically when you're doing inference, you don't need this high speed, high bandwidth networking connectivity between the instances. So it's only 100. So Inferentia is also a cheaper instance option. But you can actually train on Inferentia, which is interesting, and then you can actually do inference on Trainium. So yeah, I know it's a little bit confusing, but the holds of the
just to make it easy for everybody. But are there people doing a lot of that? Like just because you can doesn't mean you should, right? Are there people that are doing it?
So there are. So as I mentioned, so for customers who want to deploy large LLMs, like Llama 3 70B, so when you're getting into sort of towards the 100 billion parameter models, actually Trainium is actually a better choice.
Okay, fascinating to think about that. Now, what about with just like a EC2 instance?
Yeah, so on EC2, there's many different options. So we have a lot of customers who have kind of standardized on using, for example, Kubernetes, right, as their platform for doing either inference or training. So we have full support. We've even developed, a Kubernetes plugins, which will help kind of, with the resource management of, for example, we call them Neuron devices. So, for example, when you configure your Kubernetes pod, you can say, okay, I want to have, 4 Neuron devices. So it'll basically, we have a plugin that will help manage the, reserving and allocating those resources. So that's a very popular option. We have customers using Parallel Cluster. So Parallel Cluster essentially is for customers that like using a Slurm interface. It's an open source offering targeted kind of for HPC and machine learning workloads, as I said, through a Slurm interface. So that is also a popular option for training your large models. And then we always have some good collaboration with partners. So we have support in Ray. So we've worked with the Anyscale team and the Ray open source community. So for example, you can deploy your models with Ray Serve and also use the Ray Train. Just recently, we've announced support for Ray Train. So you can use their API and use Ray as a way of managing your training or inference workloads. And as well, out of bounds. So I'm sure many people are fans of the Metaflow open source project. So we had a recent blog. So they've actually added support for Trainium and Inferentia in the Metaflow platform. So that's also another great option customers like.
Nice. And last but not least, because there is such a rich ecosystem, I am wondering about Bedrock. And maybe you guys can just clarify too, when you've seen people using Bedrock versus SageMaker, what the use cases are there.
I think there's many, right? And so going back to the beginning, AWS is about offering customers choice. And so when we think about it at AWS, it's like this, we have this concept of like the generative AI stack, right? And at the top, you're going to have the services Amazon is building, like Transcribe, like Translate, things like this that are like end-to-end services where the models are integrated, the user experience is integrated, and it's just an API or service that you use. And it makes it really simple for developers to integrate, but it provides you less customizability, right? Like you get the performance you get the feature set you get, and then, over time it improves. The kind of next layer down that we've now added, which is like the Bedrock level, which gives you a little bit more customizability, right? And now as more models have become popular and to consume those models is models as a service, and that's where Bedrock really sits, right? So if you want to get access to the greatest models being produced today, right now, like from Anthropic or Mistral or, AI21 and many others, and even Amazon with our Titan series of models, right? You very quickly get access to those and other open source models, and then just consume them as an API, pay for them with a per token, tokens per dollar, right? A very simple use case there. And now you can even fine tune certain open source models as well, kind of customize them for your liking as well.
Are you fine tuning them with Trainium?
Yeah, so we utilize Bedrock, heavily utilizes Inferentia and Trainium, but also other accelerator types, right? So it uses Trainium, it uses Inferentia to kind of build and serve these models across the board. So basically all of the resources AWS has at its disposal to engage with customers. And I think Bedrock makes sense for a lot of folks, and it depends kind of where your ML expertise is, right? So if it's like, hey, we're just trying to build a really quick prototype, or we're just at the application level, we don't have a lot of folks that understand how to train models, because, as easy as it's getting in today's world, it still requires some experience to do it efficiently or to even build the services around them. So Bedrock's a great answer for that. But if you're going down the stack a little bit where you want to customize the interaction of models, you really want to own all of the data around the model and how it's being deployed and where it's being deployed. Certain applications where, are very sensitive to data residency and lineage, right? Like, where is the data coming from to train the model? Where is the servers running everything? It can't leave our borders. And this is probably more important for like European countries, which have really strict data privacy laws.
Gotta love it.
So for that, SageMaker, Inferentia and Trainium, or EC2 are going to be better options. It gives you that same kind of ease of use, but greater flexibility of where you're deploying your models, how you're setting them up, which libraries are they integrating with, what other data it's commingling with, right? Like, and if you're building a broader pipeline of services, you can co-locate your accelerators into one region to, improve the overall throughput and latency. So there's a lot of benefits, and it's really just about what are the user's objectives, what is the total the end application look like, and what's the right fit for them, and what's the right choice. And actually we have, I would say it's not an either or decision, right? So what we see a lot, or the customers we work with, they'll use services from Bedrock, right? They'll be using one model from Bedrock. Let's say that they're like, all right, I want to use one of the cloud models from Bedrock. I also want to integrate with utilizing ChatGPT's APIs, right? And so they have part of their services coming from there. And then, hey, we're going to be running all our Llama 3 models and, 70 billion parameter Llama 3 models on Inferentia and Trainium, right? And so it's kind of it gives you that choice. Like, I can get the right models for the right part of my application and build the best experiences for users and customers.
Yeah, and that in a way makes a ton of sense, just because you're giving so much resilience to your application too by having that. And so if that fully understand Bedrock now. It's like, all right, if you just want that API, that's Bedrock. It's that like OpenAI API experience in a way where you get a model, you call the API, and you're good. But if you want to go deeper, you want to have much more control, that's where you're going into the SageMaker territory or the EC2, depending. It's like there's levels and there's layers of how much control you need and want. And that is which service you're going to use depending on what you're looking for.
Yeah. I mean, if Bedrock kind of meets the application needs, like you're getting the right tokens per second, the right latencies, it has the right models that fit your application and needs, it's a great option, right? Because it's super simple. But if you need to go, kind of peel that layer back, go one layer down, that's where, utilizing or hosting your models or starting even with Jumpstart, because the experience is very similar in terms of getting started, or with utilizing the Hugging Face TGI containers. You could deploy any model pretty easily, but you have greater control, greater flexibility. You can kind of tune the variables that matter the most to to the user experience that you're trying to generate for your customers. So we get that question quite a bit as well, right? Which is, what's better, Bedrock or SageMaker or EC2? And I don't think one is necessarily better. It's just, what are the use case? What are the things that are most important to you in your applications?
Yeah, and I do like this idea too that, okay, maybe it's you're going to have a different piece of your application using different parts or different services depending on what your needs are. But also, I can imagine that you get different teams using different services too because of their needs. And so looking at it from the point of view of like, hey, if this super simple API gets you there, then no need to overcomplicate it with a bunch of services. Just use the API.
Yeah, if customers are unsure, I think always start at the easiest to use service, and then, then only really go down once you start, finding that based on your application or context that you need to. But, it's going to have a lot more costs and a lot more things to manage.
Yeah, once you hit the limits, then go deeper. But until you hit those limits, don't feel like you need to start at level hard.
That's the funny part, is like, when I would say that kind of mindset that you just mentioned is like start at level hard, right? Because I feel like a year ago, 2 years ago, when we were working with customers and users, it was always like, I have to train my own foundational model, right? And I have to do it all from scratch, and I have to set up my data, and I have to curate my data sets. And it was always starting at hard, because, there was an unwillingness to use open source to a certain degree, right? And they're in kind of enterprise environments, right? Or there was like, oh, we have to own everything. And I think that mindset has really changed with users, especially in the enterprise space. They're like, no, I can start with open source. I can start with the Llama model or a Mistral model or a Zephyr or something else, or a Stable Diffusion model. And I can fine tune it with my own data set and do it much more cost effectively and easier, and with less manpower on our side, and make, just get to market a lot quicker. And I think the idea is now is how quickly can we get it done, rather than like, hey, let's own the entire thing. Well, no, let's leverage as much as from the community as possible and contribute to the community along the way.
Okay, so you're talking a lot about what you've seen out there in the wild. I think this is a good point to transition into like actual ways you've been seeing people using Trainium and Inferentia, and what some examples are of that.
One of the key customers that we're working with is Anthropic. So towards the, in end of 2023, about September 2023, we actually have an agreement with them. So they are initially deploying Claude models onto Inferentia and Trainium. And these are actually going to go in Bedrock, as Kamran was mentioning earlier. So we're in the process of moving those across. And Kamran also mentioned earlier Trainium 2. So Trainium 2 is going to be launched very soon, towards the middle of 2024, towards the end of 2024. So yeah, Anthropic are going to be training the next gen models on Trainium. So they're a really exciting customer to work with, and to look forward to seeing those models on Bedrock.
And we've been working with kind of a range of different kind of startups and enterprise customers bringing AI into their traditional applications, right? And now leveraging the LLMs to kind of improve the experiences, to make it more user-friendly. And on the startup side specifically, we're starting to see a lot of kind of emergence of new complete products, right? I think one of those areas is, which is very, I think, gaining a lot of momentum in the market is the concept of like AI agents or autonomous agents, right? And make them very personalized to your workflows, to your company, or to yourself specifically, right? So one of these companies we've been working with that just recently launched a new service called, I think it's called My Ninja, but their company name is called Ninja Tech. They're based here in the Bay Area, and they've been leveraging Trainium and Inferentia to fine-tune their models and to deploy them at scale and to kind of serve all of their model needs. And so one of the things that's interesting about them is when they were looking out and starting, they started with, the integrations from all of the models as a service, of course, as we kind of talked about. But really quickly, they're like, you know what? We can create highly customized, very efficient models starting from utilizing open source models, right? And we're going to fine tune those models specifically for our use cases, right? Which include like, code assistants, researchers, your basic kind of like information gathering and reporting, and also scheduling tasks, right? And outperform some of the most expensively foundational models that are trained from scratch. And so with Trainium and Inferentia, they're basically able to kind of utilize, Llama 3 models to serve their customers. They're using a range of them all the way from the small 8 billion parameter code Llama models, kind of in the middle from like, 30 billion parameter and all the way to the 70 billion parameter models, and able to reduce their inference costs and their deployment costs by 80% utilizing Trainium to serve these models. And another kind of example of this is as more customers as well want to build more customized models as well, right? So we've been working with other guys that are trying to kind of create better tools in this space as well, right? So, fine-tuning models can be challenging at a certain point, right? Like there's a lot of different techniques from SFTs to TRLs to like how do you implement PEFT? What are the right techniques to not overfit your model to make sure it's as efficient as possible? So we've been working with another startup called RC.ai, and they're trying to like optimize this space where users have data that needs particular sensitivities to privacy and to security, and they can set up training environments inside of customers' domains, like in their AWS private clusters, and do end-to-end fine-tuning of models and create really highly specialized models at a fraction of the cost, right? So they're utilizing Trainium to accelerate this and seeing up to 90% cost reduction, utilizing both their domain experience, which is a combination of highly efficient LLM fine-tuning, but also a concept that they've kind of, I don't know about pioneered, but really leaning into, which is going to be small model training, right? So as everyone's trying to go to like larger models, 70 billion, hundreds of billions of parameter models, which can increase the abilities of these models. They're also thinking, well, how do I take a bunch of small models, less than 5 billion parameter models, less than 3 billion parameter models, and create a lot of specialized small models and merge them together into a final model, right? So they have this model merging technology as well, and they're utilizing Trainium to even lower the cost of building all of these models and deploying kind of for a more wide range of use cases. So great solutions across the board. So like if you're looking at, you can definitely check out Ninja's solutions. They're live now, and then RC at rc.ai as well.
Yeah, huge shout out to RC. I'm actually friends with one of their founders, Brian Benedict.
Oh yeah,
and
Brian's great.
I love that guy. I love what they're doing. The model merging is fascinating, and there's another guy in the community, Maximilian, who is doing a lot on that front too. And it feels like the model merging is something that is getting very popular, and it is getting to be, the small language models theme or narrative is also bubbling up quite a bit. I imagine you guys have been seeing it a ton too, because all in all, like if you can go smaller and you can still accomplish your goal, then it's going to be much better to be smaller because it's faster, it's cheaper.
Yeah.
Like, what more can you ask for?
And I think that's the hidden cost that people don't realize. They're like, well, okay, fine, I can train my model and it's a one-time expenditure. So, I'll bite that bullet. I'll train my 70 billion parameter or 100 billion parameter model or maybe more, and it costs me X dollars. But now if you want to serve it and keep that real-time, low latency, high response engagement with your user to actually use that model, it can be very expensive to do so, right? Now, Inferentia and Trainium help reduce those costs, but it is still more expensive. So if you can accomplish the quality of model at a fraction of the model size, you have your deployment options open up, right? Now you can use smaller instance sizes, less compute. You can scale further without, kind of like investing more in compute cost and operating cost. So I think there's a lot of potential here as I think we're optimizing, or the industry's optimizing in two fronts, right? Like one is how do we make, models more capable and expand their use cases? So that's going to, build super large models. But at the other end of it, how do we make small models more efficient? And so I think we're kind of seeing both of those trends, and RC is definitely on the, they're kind of across the board, but really I think I'm excited to see what they're doing with small models and model merging.
Have you guys seen agents that have been working well in production?
Yeah, absolutely. Actually, Ninja is one of those companies. They're actually using a few different models that are all running on Inferentia and Trainium to serve their agents. It's great solution as well. But I think we're going to see a lot more agents, and Amazon launched their Q products, which is also trying to help in this space, right? Personally, I think we're going to see agents kind of infiltrate all aspects of our lives as we move forward, right?
Yeah.
Like I just saw that Google is replacing their Google Assistant on all of their Android phones and tablets with Gemini, right? So they made that announcement as well. So I think agents are in our future across the board, right? But I think the differentiator will be is good high quality agents, not just let me ask you the weather or who won the basketball game last night, but like very specific and personal. And, it's going to require being able to kind of deploy and fine tune these models in a more of a kind of like a reinforcement learning technique where they're constantly learning about you, your habits, and then implementing that or updating the models as fast as possible.
Excellent, fellas. Well, this has been awesome. I appreciate you all coming on here and talking to me about this because I know there's a lot of confusion and just people want to use it. Just now, I was looking through the MLOps community Slack, and somebody's asking about GPU resources in AWS and what's this and what's that. So I guess the last question I've got for you, I imagine there's some kind of a chart that you all have as far as, well, if you're looking for this type of GPU, you'll probably be good with this instance of Inferentia or Trainium. Does that exist? And if not, can we make it?
I would say a good starting point is our documentation. So we have the Neuron SDK documentation. I assume we can put a link in the show notes. And there we have a lot of information. So for example, tutorials, getting started guides, and we even have a performance table of all the most popular open source models, such as Llama 2, Llama 3, Mistral, Stable Diffusion models, BERT, and which instances it can be deployed to and what kind of performance you can get. We have different combinations, right? Depending if people are optimizing, they really need, say, low latency. Obviously, you probably will need to use more accelerators, or maybe optimize for costs and use fewer. So we have many different options there. So I'd encourage folk to check out our documentation and give it a try.
Awesome. I love it, guys. Thanks for doing this. And it feels like I've learned a ton all about Inferentia and Trainium. And especially, I like the fact that it's not joined at the hip. You get to choose, it's choose your own adventure when it comes to this. You're able to save this 46% cost is huge. And being able to get that, then also the idea of start simple and go down the stack as need be. When it gets more complicated or you find you're hitting your limits, then you can go from that Bedrock to the SageMaker to the EC2 or whatever it may be. But it's cool to know that all along the way, if you're using or utilizing Trainium or Inferentia on any of these services, you can keep utilizing it. And it's not like, oh, this only works with Bedrock. So it's nice to see that that's like the Amazon way, I guess, that you probably wouldn't be able to ship something if it could only work with one of these services. I think that's enough people have written about that. Books have been written on that subject, but that's not for today. I'll let you guys go. This was awesome.
Thanks.
Thanks very much. It was fun.